Hello all. Aakriti Educations brings you the analysis on previous year IIT-JEE questions. In this video, we will discuss question number 13 of section 3 asked in IIT-JEE Advanced Paper 1 2020. The question says, let small m be the minimum possible value of log 3 raised to the power y1 plus 3 raised to the power y2 plus 3 raised to the power y3 to the base 3, where y1, y2, y3 are real numbers, for which y1 plus y2 plus y3 is equal to 9. Let capital M be the maximum possible value of log x1 to the base 3 plus log x2 to the base 3 plus log x3 to the base 3, where x1, x2, x3 are positive real numbers, for which x1 plus x2 plus x3 is equal to 9. Then we need to find the value of log small m cube to the base 2 plus log capital M square to the base 3. Okay, so in this question, logarithmic and exponential functions are given. Let f of x is any logarithmic function given as log x to the base a, then it is valid when x is greater than 0 for all a belongs to open 0 to 1 union open 1 to infinity, and its values are from all the real numbers. Similarly, if g of x is any exponential function given as a to the power x, then it is valid for all x belongs to R, for all a belongs to open 0 to open 1 union open 1 to infinity, and its range is all the positive real numbers. So using this information, 3 to the power y1, 3 to the power y2 and 3 to the power y3, since they are the exponential functions, so they all will give the positive values, and their addition will give the positive values for all y1, y2 and y3 belongs to real number. Hence, log 3 to the power y1 plus 3 to the power y2 plus 3 to the power y3 to the base 3 is defined for all the real values of y1, y2 and y3. Similarly, it is given that x1, x2 and x3 are the positive real numbers. It means log x1 to the base 3 plus log x2 to the base 3 plus log x3 to the base 3 is defined. Now, let's go to the solution part of this question. This question is based on the AM-GM inequality. This inequality says if there are the n real numbers p1, p2 up to pn, then am of these numbers, which is given as p1 plus p2 up to pn divided by n, is always greater than or equals to gm of n numbers. Gm of n numbers is product of numbers raised to the power 1 by n. This expression can be simplified for two numbers. When n is equals to 2, then p1 plus p2 by 2 is always greater than or equals to p1 into p2 raised to the power half. Similarly, for n is equal to 3, this expression is simplified as p1 plus p2 plus p3 divided by 3 is always greater than or equals to p1 into p2 into p3 raised to the power 1 by 3. This equality holds when all the numbers are equal. Now, we will use this AM-GM inequality to solve our question. So, let P1 is equal to 3 raised to the power y1, P2 is 3 raised to the power y2 and P3 is 3 raised to the power y3. So, if we apply the AM-GM inequality, then AM of this number is always greater than or equals to GM of this number. After simplifying, we achieve that 3 raised to the power y1 plus 3 raised to the power y2 plus 3 raised to the power y3 divided by 3 is always greater than or equals to 3 raised to the power y1 plus y2 plus y3 divided by 3. Since y1 plus y2 plus y3 is given as 9, so after simplifying, we will get 3 raised to the power y1 plus 3 raised to the power y2 plus 3 raised to the power y3 is always greater than or equal to 3 raised to the power 4 as given in equation number 1. Now, we need to find the minimum possible value of log of this value to the base 3. So we need to take logarithm on the both sides of this equation. So first we see that how the inequalities in log work. So let's say if x and y are two real numbers such that x is greater than y, then log x to the base b is always greater than log y to the base b if base is greater than 1. Otherwise, the inequality changes its sign. So we will use this inequality since we have to take the logarithm to the base 3. It means the base value is greater than 1. So sign of inequality will not change. Now by taking the log to the base 3 both the side, we get log 3 raised to the power y1 plus 3 raised to the power y2 plus 3 raised to the power y3 to the base 3 is always greater than or equal to log 3 to the power 4 to the base 3 since base is greater than 1. Now, as we know that log a to the power m to the base b can be written as m times log a to the base b. So, by using this, we will find that log 3 raised to the power y1 plus 3 raised to the power y2 plus 3 raised to the power y3 to the base 3 is always greater than or equal to 4. Hence, the minimum possible value of log 3 raised to the power y1 plus 3 raised to the power y2 plus 3 raised to the power y3 to the base 3 is m is equal to 4. Now, similarly, by applying the AMGM inequality on three numbers x1, x2 and x3, we get AM of these numbers as x1 plus x2 plus x3 by 3 is always greater than or equals to GM of these numbers, which is x1 into x2 into x3 raised to the power 1 by 3. By using the information as x1 plus x2 plus x3 is equal to 9, we get 3 is greater than or equal to x1 into x2 into x3 whole to the power 1 by 3. By taking the logarithmic with base 3 on the both side of equation 2, we get log 3 to the base 3 is greater than or equals to log x1, x2, x3 to the power 1 by 3 to the base 3. After simplifying, we get 1 is greater than or equal to log x1 to the base 3 plus log x2 to the base 3 plus log x3 to the base 3 whole divided by 3. Here we have used one identity in the logarithmic which is given as log xy to the base b can be written as log x to the base b plus log y to the base b. So further simplifying, we get 3 is greater than or equal to log x1 to the base 3 plus log x2 to the base 3 plus log x3 to the base 3. Hence, the maximum value of this expression is capital M is equal to 3. Now we need to find the value of log m cube to the base 2 plus log capital M square to the base 3. So by putting the value of small m and capital M and further simplifying, we get the value as 8. Thank you all. If you find the video interesting, please like, share and subscribe our channel for more updates.